All right, very good. Tara, R5 on the review homework. All right, get to that page. All right, this is on page 701, R5. Okay, so it says that we have 5 marbles that we're selecting from a bag without replacement. That means once we select one of the marbles, we don't put it back in. Um, and the bag originally contained 7 red marbles, 7 red, and 9 blue. Use some color coding, 9 blue. And that is a total of 16 marbles. So we know the total, and we know specifically that there are 7 red, 9 blue. So students in my class, you know that I've told you that I think you should try to categorize the different types of problems. Okay, so I don't even know if we've ever done a marble problem before. But when they give you the specifics about how many are red, how many are blue, I want you to think of that as the same type of problem as, I think we talked about this in one class, but maybe not the other, the Charlie Brown sock problem. And I'm not even sure if you guys did that problem in your homework, but where they tell you how many green socks and how many blue socks Charlie Brown has. What else? We had something on the quiz that was like that, um, where they tell you you're selecting a group of 6 that's selected at random, and you had history teachers and math teachers. They're telling you specifically how many of each you have. Then you had another question on the quiz that was 7 Republicans and 7. Well, that was a circular permutation, so that's a little bit different. But all of those problems have something similar. And actually, the 2 bracelets and a necklace question on the back of the quiz, where they tell you there are 10 bracelets and 7 necklaces. Do you see the similarities with all of those questions? They're telling you how many you have all together, but then specifically specifying how many, in this case, are red and how many are blue. All right, so all of those problems have something similar, and that is that you don't care about the order. You just want to know how many you're going to end up with. And so it's going to be a combination, not a permutation. I think that's a very big deal, asking yourselves if the order matters or not. If the order matters or not. All right, so 5 marbles are selected from a bag. That's very important, that you know that it's 5. Then it says the bag originally contains 7 red marbles and 9 blue ones. And then I totaled those and said that's 16 marbles. Okay, what is the probability that exactly 3 are red? All right, so let me change the color to black. I'm going to go P for probability. And then if I just write 3 are red, I probably will only think about the red marbles. But remember at the very beginning, it said 5 marbles are selected from a bag. So that means there are 3 red and 2 blue, right? Because it said exactly 3 are red. Well, since I'm selecting 5, I have to have a total of 5. So out of the 7 red marbles that there are, I'm going to choose 3. And then, so it's times, out of the 9 blue ones, I'm going to choose 2. And so I'm saying the word choose, but of course the C stands for combination versus permutation. Because if I select the 3 red marbles that I'm trying to end up with as the first 3 choices, great. But if I choose them as the last 3, I still have 3 red marbles. So the order doesn't matter. Okay. And then since this is probability, of course, I have to divide by the sample space. Now, the sample space, you want to remember, means there's nothing specific, nothing about the red, nothing about the blue, just I'm selecting 5 marbles out of the 16. So 16, choose 5. That's my sample space. All right, and I hope the answers are here so I don't have to waste time doing it in my calculator. All right, they actually have everything spelled out here. Very nice. So this is 35 is the 7C3 times 36, that's the 9C2, and then divided by, yeah, divided by 4368. That's the denominator, 4368. That's the 16C5. And then that ends up being approximately 0.288. And so they went with an approximation of 28.8% chance of having exactly 3 red marbles. Okay, so you see how the setup, and I personally think, let me do this in red, this part right here is so important because if you just put P of 3 red, you're going to forget about the 2 blue. Okay, all right, that was part A and then part 1. Part 2 says at least 3 are red. Okay, so since we're selecting 5, that means either 3 are red or 4 are red or 5 are red. Well, we already did the 3, so I'm not going to do that again. Okay, then I'm going to write or the probability that 4 are red, and if 4 of them are red, then 1 of them is going to be blue. I know I'm doing that all in red, but anyway. So this is going to be out of the 7 red, choose 4, and then out of the 9 blue, choose 1, and then of course over the same 16C5. That ends up being, oh, well, let me continue on. And then I also want to do the probability of 5 are red. Now you could say and 0 are blue, but doing out of 9, choose 0, you end up just getting times 1. So that doesn't change anything. So this is going to be out of the 7 red, choose 5, and that's it. And then over the sample space, I may as well just write the sample space right there. Okay, and then it's the first one or the second one or the third one. So of course we're going to add these all up. Okay, so let's see here. This is part 2. Okay, so the 4 and 1 ends up being 315. This one is 315 over the 4368. And then the 5 and 0 ends up being 21 over 4368. Okay, so when we add those all up, you know what, I didn't put that total 35 times 36. I have it though. It's 1260 from the first part of the question. Okay, so I know this is a lot of work here. I've got 1260 plus, for the word or, 315 plus 21, again, the word or, and then that's all over 4368. Okay, so our final answer for the at least 3 ends up being approximately, kind of out of room here, I'm going to go all the way up here. It ends up being 36.5% approximately. 36.5% when you add that all up. Okay, then part B is a whole different situation. So this is R5B now. Okay, so it says Mr. Ree's car has a probability of 0.7 or 70% of starting, and Miss Ree's car has an 80% probability of starting. What is the probability that, and then they ask you a bunch of questions. All right, so I'm going to say the probability of, I'm going to put capital M for man, not for Mr. because then his wife's Mrs. and that's also an M, but probability of the man's car starting is 0.7 and the probability of the woman's car starting is 0.8. Okay, so 70%, 80%. And I'm writing the decimal equivalent. Okay, so what is the probability that neither car will start? Okay, and as I mentioned before, I think this notation right here that I'm going to write is very important. Okay, neither car will start. I'm going to say the probability that Mr. Ree's car does not start. I'm going to call that not M, and at the same time, not W. Okay, do you understand that? It's the capital M stands for Mr. Ree's car will start, and the capital W stands for the woman's car will start. So this is not and not. And so his not is 0.3 and her not is 0.6. And so we get 0.2 for a product of 0.06. Okay, so 6% chance that neither car will start. Okay, and then part 2 says both cars will start. So the probability that the man's car starts and the woman's car starts, so that's 0.7 times 0.8, the two probabilities they gave us, so 0.56. Okay, and of course that's 56%. Okay, you can either write it as a decimal or a percent. either both cars or neither car will start. Either both cars will start or neither car will start. And so that's just adding those up. Okay, so the 6% from neither car will start plus the 56%. And so we get 62% for part 3. I. All right. And then finally it says exactly one of the cars will start. All right, so to do that one, I can actually, because they asked for the sum of the neither car will start or both cars will start, well, I can just say probability of exactly one, oops, exactly one car will start. It's everything except for what we just found. So I'm going to do 1 minus 0.62 and I get 0.38 or 38%. Now you can calculate that a different way. You can say the probability of M and not W, or, so of course that means plus, I will not take that call right now, or the probability of not M and yes for W. Okay, so you could do both of those and then add them together and you'll end up getting 38%. Okay, but it was a heck of a lot easier to do the 1 minus 0.62, right? Okay, Tara, that was your R5 part A and B. Okay, then Zoe, can I do oh gosh, all right, silent. Okay, all right, Zoe, can I do 13 and 22 on the review worksheet? Yes. Okay, let's call it review worksheet number 13. All right, so 12, 13, and 14 kind of go together. So this is saying in Orange County, 60% of the voters are in favor of school bond A. Okay, so the probability, we're going to say, of bond A passing is 0.6. And then 30% are in favor of school bond B. So the probability of bond B passing is 0.3. Okay, so in number 13, they said neither bond will pass. I'm going to keep on saying it. I think if you just try to start working with numbers, it kind of gets confusing. Okay, but when you kind of like clearly do this notation, it just sets you up for doing it correctly. And as you keep practicing, then you're going to start to realize, oh, I just keep doing the same thing. All right, so the probability of, it says neither bond will pass. So what about A? No, it's not going to pass. So not A. Okay, and then what about B? It's not going to pass either, so not B. Okay, so do you see how I'm writing my notation? That P for probability of A not passing and B not passing. Neither bond will pass. All right, so if the probability that bond A will pass is 0.6, then 1 minus that, or 0.4, is the probability that it won't pass. And then since I'm saying and then, that means times, then the probability of bond B passing, they told us was 30% or 0.3. I'm going to do 1 minus that, so 0.7 for the not B. And then you multiply those together and you get 0.28, which is 28%. Okay, and that's the answer to number 13. Okay, let's see. Zoe's also asking for 22. All right. Actually, I'm going to do 21 and 22. So review worksheet numbers 21 and 22. All right, we are going to ask you for the definition of NCR and also NPR. Okay, so NCR starts with N factorial divided by R factorial and also divided by N minus R factorial. So NCR has more things, more factors in the denominator. That means you're going to get a smaller number than NPR if your N and your R are the same numbers. NPR is N factorial over only N minus R factorial. There's no R factorial in the denominator. Okay, so your NPR will always be a bigger number because the order matters. Okay, and let me just write that right here. Permutation, the P of course stands for permutation, means that order matters. So if, for instance, you're talking about selecting 3 books out of 8 books from your locker, okay, but if I don't care about the order, then it would be 8C3, okay, if order doesn't matter. But if order does matter, out of your 8 books, go and pick 3, and that's kind of how I like to say this. For the 8C3, I say out of the 8 books, choose 3. And then for 8P3, I say out of the 8 books, pick 3. The C obviously stands for combination and the P stands for permutation, but I use the word choose and pick, which really just means select. Okay, so if you choose 3 books out of the 8, you're just wondering, like, what are the 3 books you ended up with? Math, history, English, or something like that. But if it's 8P3, and I want to know the order that I'm going to put them on a shelf, and if I have math and history and English, well, I also could place it on the shelf like this, math, then English, then history, but I can also place it on the shelf, English, history, math, and I can go English, math, history, and I can go history, English, math, and I can't squeeze it in, history, math, English. Okay, so 6 different arrangements, and that's a key word for permutation, arrangements, that's messy, 6 different arrangements for the same 3 books. So that's why your 8C3 will be a much smaller number than 8P3. Let me do it. 8C3 is only 56 over here if I don't care about the order and I just want to know that I have math, history, and English. But 8P3 is 336, which, by the way, 56 times 6 gives you 336. And so you see that there were 6 different arrangements that I just wrote out for my one combination of math, history, and English. Okay, so that's kind of a review of that. So now I'm going to put it to practice on this 21 and 22. So 21 said, write out the formulas for 15C4, and then for 22, they wanted us to do 13P2. All right, so 15C4, that's going to be 15 factorial, that's my N factorial. R factorial is my 4 factorial, and then I go 15 minus 4, which is 11 factorial. So that's your answer for 21. 22 is going to be N factorial, which is 13 factorial, and then just divided by 13 minus 2, or 11 factorial. And that's your answer for number 22. Okay. All right. That was Zoe's question. Okay, Zach, 4 and 5 on the quiz. All right. Quiz number 4. Okay, if a group, a lot of groups miss this, by the way. If a group of 9 is picked at random, so by the way, they told us in the directions that there were 6 math teachers and 6 history teachers. Okay, so I'm doing M for math, H for history. Okay, so we know that there are 12 teachers altogether that we're considering. So it says if a group of 9 is picked at random, what is the probability it contains exactly 4 math teachers? And then they told us to leave it as a simplified fraction. All right, this is again one of those that I think if you didn't write this notation, you probably only were thinking about the 4 math teachers. Okay, they said 4 math teachers, but at the very beginning of this sentence, it says if a group of 9 is picked at random. So yeah, I want 4 math teachers, but that means and 5 history teachers for a total of 9 that we're selecting, right? And then remember how at the beginning I was saying try to categorize your types of problems. Even though this isn't Charlie Brown's blue and green socks, and it's not, what did we do at the beginning? I think, oh, it was the marbles, red marbles and blue marbles. It is exactly the same type of problems. I know I have a total of 12 teachers, and I know exactly how many of them are math teachers and how many are history teachers. So out of the 6 math teachers, I'm going to choose 4. The order doesn't matter. And then, so times out of the 6 history teachers, I'm going to choose 5. Okay, and then this is probability, so I need to divide by the sample space. Now you don't think about the specifics about how many math and how many history. It's just out of the 12 teachers total, I'm going to choose 9 because that's what they told me is we're selecting 9 teachers altogether, or getting a group of 9. Okay, so this ends up being 15 times 6 divided by 220. It is 90 over 220, and they ask for a simplified fraction, so 9 over 22 is my final answer. Okay, for number 4. All right, number 5, same scenario about the 6 math teachers and 6 history teachers. This time it says if a group of 6 is picked at random, what is the probability it contains at least 5 history teachers? So I'm going to write probability of 5 history, but remember they said they're selecting 6, a group of 6. So if there are exactly 5 history teachers, and I know they said at least, but right now I'm doing exactly 5 history, then doesn't there have to be 1 math? Okay, and then I'm going to say, or since it's at least 5 history teachers, it could be 6 history teachers. And since we're selecting a group of 6, that's it. There wouldn't be any math teachers, which would be very sad. Okay, so again, we have 6 math and 6 history teachers in this group of 12 teachers total. And so I say out of the 6 history teachers, choose 5. And out of the 6 math teachers, choose 1. And then again, my sample space is out of the 12, choose 6. I guess I shouldn't say again because this is a different problem than number 4. We only have a group of 6 instead of a group of 9. But the sample space is found similar to what we did on the last problem. Out of the 12 teachers total, choose 6. Okay, then for the probability of having exactly 6 history teachers, I'm going to say out of 6, choose 6, and then same sample space. Okay, so let me get this. My 6C6 down here is 1 out of 924. And the other one is 6 times 6, or 36, out of 924. So we add those together and get 37 over 924, and that fraction does not simplify. So there you go. Okay, I hope you're starting to see a trend with these types of problems. It doesn't matter if it's red marbles and blue marbles, green socks and blue socks, 6 math teachers, 6 history teachers. It's the same concept that you know how many of the specifics you have, and then you're selecting or choosing because the order doesn't matter. And then your sample space, of course, is out of the total, how many ever total marbles you have, or how many ever total socks you have, or in this case, how many total teachers you have. Okay, let's see. Addie is asking for R4, B, and C. Okay, R4. Okay, so we're using the word or the letters in the word sardine. This is page 701, R4. And then you're asking specifically for B and C. We might have to do more. Okay, so let me write the word sardine. So 1, 2, 3, 4, 5, 6, 7 letters. I'm just kind of glancing to see if any of them repeat, and they don't. That's very important. Okay, so I'll just do part A. They said how many different linear arrangements could be made using all the letters? Well, there are 7 letters, so for part A, it would be 7 factorial. Okay, and find it, that would be 5,040. Okay, and the reason I wanted to do that one is that's your sample space. Okay, part B. How many of these arrangements have D first and a consonant second? Okay, and by the way, when you're writing words, the order matters, okay? And this is really, really important. When you do these lines that I'm getting ready to do here, 2, 3, 4, 5, 6, 7 lines, when you do those lines, you are doing a permutation. So you're implying that the order matters when you do this, and it does. Okay, so I'm going to write underneath the first letter, the letter D, because that's what they said. And then I'm going to write consonant, abbreviation for consonant. Okay, and then the remaining 5 letters, no stipulations. Okay, well, there's only one D, so there's only one letter that could go there. Now, out of the whole word sardine, there's 1, 2, 3, 4 consonants, but D is one of those consonants, so that means there would be 3 consonants left for the second spot. Once I filled those 2 spots, there are still 5 letters left. And so then you go 5, 4, 3, 2, 1. Okay, and when you multiply those all out, this is R4B, that gives you 360 ways that you could do that. Okay, and then part C says, if an arrangement is selected at random, arrangement is that key word, right? That means the order matters. What is the probability that D comes first and a consonant is second? Well, that's what we just did in part B, but now they're asking for the probability, not just the number of ways. So the number of ways was 360, but I'm going to divide it by the sample space, 5,040. And so, let me just double check that. 360 divided by 5,040. All right, so I get approximately, change that to a squiggly equal sign, 0.0714, which is approximately 7.14%. Okay, there you go. So you see why I did part A, because I needed that to be able to do part C. Okay, let's see. That was Addie's question. Costin, 13 on the quiz. All right. Okay, this was bolded because they had asked you in number 10 and 11 and 12 for probabilities. And then when you get to 14, suddenly they don't ask you for a probability. They ask you how many ways. So they bolded that how many ways. And there were a few groups who still did a probability. Okay, so if you can picture, that's supposed to be my hearts column. So I've got ace 2 through 10, and then jack, queen, king. Okay, so there are 13, whoops, bad circle, but anyway, 13 hearts. Okay, and then they say, or a face card. Well, those are my heart face cards, but I also have 3 diamond face cards. And then let's switch to black. I've got, oh, that's a bad spade, but 3 jack, queen, king spades, and then 3 face cards for my clubs. Okay, so all together I have 12 face cards, but didn't these overlap right here? Because that, what I'm circling right here, jack, queen, king of hearts, I counted it in the 13, and I also counted those in the 12. So if you just add 13 plus 12 and get 25, that's incorrect because we double counted the jack, queen, king. That was a heart, that were hearts and face cards. So I'm going to subtract 3, and so I get 22. And that's all they wanted to know was 22. Okay. All right. Let's see. That was Costin's question. Oh, I wrote 13, or I wrote 14, but it is number 13. Okay. Let's see. Andrew, 5 and 6 on the quiz. I think we already did those. I didn't do 6. I did do 4 and 5 though, so your number 5 has already been done. All right, quiz number 6. How many arrangements? That word arrangements tells me that it's a permutation, not a combination, because the order matters. How many arrangements can be made using all the letters in the word scramble? Scramble. So you should look to see if there's any repeating letters. So there's only one S, there's only one C, R, A, M, B, L, E. There are no repeating letters, and there are 2, 4, 6, 8 letters altogether. So how many? 8 factorial, and that is 40,320. Okay, now I'm going to go ahead and do the other question on the quiz where there were repeated letters. Where is it? There it is, number 8. Albuquerque. Okay, and they weren't exactly nice because sometimes they'll tell you which letters are indistinguishable. It just said how many different arrangements can be made using all the letters in the word Albuquerque. So ALB, UQ, another U, ER, another Q, another U, another E. All right, so there are 11 letters. You need to count how many letters there are. Okay, but I'm going to underline that there's 1, 2, 3 U's. Then let's see, the Q's, I'm going to put a little line above it. There are 2 Q's. And the E's, I'm going to circle 1, 2 E's. And let's check the other letters. A, there's only one. L, there's only one. B, there's only one. And R, there's only one, but the other ones are repeated letters. Okay, so if there were no repeating letters, it would be 11 factorial, and some of you put that as your answer. That's not correct. This is a special situation because there are repeating elements. So the 3 U's, if I were to switch 2 of those U's, you wouldn't be able to tell the difference because you can't tell the difference between those U's. That's called indistinguishable. All right, so I have to divide by 3 factorial because there are 3 U's. Then I have to divide by 2 factorial because there are 2 Q's. And then I have to divide by another 2 factorial because there are 2 E's. And so that ends up being 1,663,200. Okay, all right. Let's see. That was Andrew. Okay, Phoebe, can I do the last 2 questions on the homework worksheet? Yes. All right, this was for tossing 4 coins. All right. Okay, so they didn't actually ask you to do this. Let me write worksheet number 23. They didn't ask you to do this, but if you have 4 coins, I'm going to call it coin 1, coin 2, coin 3, and coin 4. Okay, I'm going to write all of the different possibilities. There are 16 of them. All right, so you could have heads for all of them. Then I'm going to put 1 tail and I'm going to put it in each of the 4 spots. Okay, so that's 1 tail with 3 heads. But do you see how I'm doing it kind of systematically? Because otherwise it'd be very easy to get confused. So I put the tail, the 1 tail in each of those spots. Okay, we've got 5 so far. There are 16. By the way, it's for each coin you have heads or tails, so that's 2, right? So it is 2 to the 4th power because you have 2 and then 2 and then 2 and then 2. So it's 2 times 2 times 2 times 2, and that's how I get 16. So today on the quiz, if you didn't know that your sample space was 16, that creates a problem. All right, now I could have 2 tails, so I'm going to put them there and there, then here and here, and there and there. That is not it. If I have 2 tails, I've done that, but it could be the 1st and the 3rd spot, 1st and the 4th spot. I haven't done the 2nd and 4th spot. I think I got all of those. I'm not positive. HH. I have 2 H's on each of these rows. And then I know I haven't done 3 tails. So let me do that next. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. I'm going to count how many I have so far. And then, of course, all 4 of them tails. Okay, I hope that's 16. 2, 4, 6, 8, 10, 12, 14, 15. Dang it, what am I missing? I did 3. I think it's my 3. 1, 2, 3. Oh, I know. I didn't put an H right here. It's easier to actually look at the 1. So I had an H alone with the 3 T's in the 4th spot, then the 1st and the 2nd, and I missed the 3rd. Okay, so T, T, T. Okay, I went a little bit out of order there. There are all of them. They didn't ask for them, but I just wanted to show you that there really are 16. Okay, but it's 2 to the fourth. By the way, if there are only 3 coins, then it would be 2 to the third, and that's 8 possible outcomes. Okay, so those are my 16 of my sample space. So when they say all the coins are heads, well, all you have to know is that there are 16 of them total. And then for 23, all the coins are heads. There's only one of those. So 1 out of 16 is my answer. Okay, and then number 24, they said at least 3 coins are heads. So that means 3 or 4 are heads. So let me change the color. Let's see, 3 or 4. I'm going to put a little red mark here. There's 4 heads. Here's 3, 3, 3, 3, and that's it. So 2, 4, 5 out of the 16. And so 5 over 16 is my answer for 24. Okay, there you go. Okay, let's see. Leon, I was just looking down at some of the things. For the people who have Brooke, did we have, okay, I don't know what her assignment was. So Leon, I am not sure who your teacher is, but I gave the review to my students yesterday. And so different teachers may have given them on different days. Okay. And Kendall's saying you might get it tomorrow. Okay. Okay, let me see. Ooh, there's a lot of questions here. I don't know that we're going to have enough time for all of these. Okay, I'm up to Melissa. Okay, hi Melissa. Can I do number 1? Oh, change to 13. 13 on the quiz. Yes, if I haven't already done it. I already did it. Okay, I've done that. Josh, that page number 5, 6, 6, 7. Page 6, 6, 7. And you said number 5. Okay, this is the traffic light problem. Okay, so this is the concept that you know what the probability is because they tell us. And then, oops, page 6, 6, 7, number 5. And then we know that the not is going to be 1 minus that probability. Okay, so 2 traffic lights on Broadway operate independently. Your probability of being stopped at the first one, so I'm going to call it probability of 1, okay, getting stopped at the first light is 0.4. I don't usually write this, but let me do it. The probability of not 1 would be 0.6, 1 minus the 0.4. Okay, the probability of getting stopped at light 2, they tell us, is 0.7. And so the probability of not getting stopped at 2 is 0.3. Okay, so that's the 0.4 and 0.7 are the getting stopped, and then not getting stopped is the 0.6 and 0.3. Okay, what is your probability of being stopped at both lights? Okay, so I'm going to say it again. If you don't write some kind of nice notation right here, you're probably going to get messed up. I just think this really makes it easier and kind of sets you up to do the problem correctly. So the probability of both lights, that means I want to stop at 1, right? Being stopped at both lights. So 1 and 2. So it's 0.4 times the 0.7 because it's and, so that's times. So I get 0.28, which is 28%. Okay, that is number 1 or 5A. Neither light, so that means the probability of not getting stopped at 1 and not getting stopped at 2. So now I'm going to multiply the not values. So 0.6 times 0.3 is 0.18 or 18%. Okay, that was B. C says the first but not the second. So the probability of 1 and not 2. Do you see how my notation just totally sets you up to do it correctly? So getting stopped at 1 is 0.4, but not getting stopped at 2 is 0.3. And so I get 0.12 or 12%. Okay, D, the second, but not the first. I'm actually going to do it in this order. I'm going to go P of not 1 and yes for 2. I just want to kind of stick to the order of 1 and then 2. even though they said getting stopped at the second, but not the first. So I'm switching the order. Okay, so not the first is 0.6, and yes at the second is 0.7. So 0.42 or 42%. That's the answer to part D. And then finally, exactly one of the lights. Um, so um, exactly one means to add these two, right? Because exactly one means stopped at one but not the other, or stopped at two but not the first, right? So I'm going to add these two together and I get 54%, and that is my answer to part E. Okay, there you go. Okay. Alrighty. That was Josh's question. All right, Kendall, can I do R4A? I need help knowing when to use that and that. Okay, so Kendall, as I'm getting to that question, I'm not sure if I've done it or not yet. And CR is a combination, the order does not matter. And PR is a permutation, the order does matter. And that is exactly what you need to ask yourself, is whether the order matters or not. Okay, so R4, that was the sardine question. I have already done at least A, yeah, I've done A, B, and C. And what did you ask for? R4A. So I've already done that one. 2, 4, 6, 7. There were 7 letters. It's just 7 factorial. And the order does matter. So by the way, I will write this R4A. I said 7 factorial because do you agree if you wrote out the little lines to say 4, 5, 6, 7, let's write out the letters. Well, there are 7 possible letters that could go for the first spot, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. And because of the and thens, of course, we're multiplying them. So of course it's 7 factorial, right? Which ends up being, let me find it, 5,040. I'm not going to redo this problem, but I just want to make this comment. Whenever you do the lines like I'm doing right here, that is a permutation. So you could have said out of the 7 letters, pick 7. And I'm saying pick for P, but really it's a permutation because the order matters. And if you do 7P7 in your calculator, you will also get 5,040. Okay? All right, let's move on. Okay, Josh, number 4 on the quiz. I think I have done it. Yes, I have. Okay, so let's move on. Hold on just a second. Okay. Cameron, number 5 on the quiz. I think I've done that one. Yes, I have. All right, Sarah, R4A and E be the same answer. Oh, let's look. E, okay, if the letters were changed to Amanda's, all right, so it's no longer the word sardine. How many different linear arrangements could be made? All right, E, yeah, R4A and R4E have nothing to do with each other. So let me do that right here. R4E. So a man does, okay. I mean, it's not even close to being sardines. Anyway, I have 2, 4, 6, 7 letters, and 2, 4, 6, 7. Sardine did also have 7 letters. However, this has 1, 2, 3 A's. So I'm going to start off with 7 factorial, but then I have to divide by 3 factorial. M, there's only 1, N, there's only 1, D, there's only 1, S, there's only 1. So that's it. 7 factorial divided by 3 factorial, and that ends up being 840. Okay, so just 2 different questions. Okay, let's see. Addie, could I do 19 on the worksheet? Okay, we haven't done that yet. All right, so 15 through 20, they are talking about rolling 2 dice, a black die and a white die. Okay, so if the white die, let's go like this, white and black, this, I'm not going to do the whole chart, but if the white die is a 3, then aren't there 6 possible, right? 1, 2, 3, 4, 5, 6 of those 3s that could come up in our rollings, right? And then for the black die, if it's a 5, aren't there 1, 2, 3, 4, 5, 6 of those also? But when you look at what I just circled, this one is an overlap. So it's not just 6 plus 6, it's 6 plus 6 minus the one that overlaps. So there are 11, and then of course my sample space is 36, and they ask for the probability. So this is 11 out of 36. Okay, that was number 19 on the worksheet. Okay, let's see, that was Addie's. Okay, Izzy is asking for 2, 4, and 15. All right, 2 I will do, but 4, I have not done 4. I'm sorry, I was going to say I've already done, but that was on the quiz. Okay, so worksheet number 2. All right, how many ways can the 6 Democrats, let me write 6D and 6R, 6 Democrats and 6 Republicans arrange themselves if Democrats and Republicans are alternating? Okay, I want to do that. Yeah, 2 and 4. I want to kind of compare them. So those are 2 good questions to ask together. Okay, so in number 1, they asked how many ways can they arrange themselves in a line. So that's just the total number of politicians is 12, so it would be 12 factorial. Or you could say, because you're arranging them, out of 12, P, pick 12. Okay, so 12P, 12 is the same number as 12 factorial. Okay, so for number 1, it's 479,001,600. All right, but then 2, your question says, how many ways can they arrange themselves if Democrats and Republicans are alternating? So it's implying in a line. Okay, so I'm not going to draw out 12 lines, but let me just start it. So if we start with a Democrat and then go Republican, Democrat, Republican, etc. Okay, there are 6 Democrats who could be in the first spot, and then 6 Republicans who could be in the second spot. Once one of each of those have been placed, now there's only 5 Republicans, and I said that wrong, 5 Democrats and then 5 Republicans, and then 4 and 4 and 3, etc. Okay, so do you agree this is 6 factorial times 6 factorial? Okay, many of you put that as the answer. However, if we said, okay, now that you guys have lined yourselves up, whoever is in the first spot, you're going to be president. Well, there's a big difference in this first arrangement where I already put the Democrat first compared to the second arrangement where I put the Republican first. So they're both alternating, right? And the numbers are all going to be the same, but it's either the first arrangement or the second arrangement. Those are definitely different arrangements. So you need to take this number and multiply it by 2. Okay, so you double that. And so the answer ended up being 1,036,800. And so let me take that number. Actually, let me just go 6 factorial squared. If you got 518,400, if that number sounds familiar, you didn't multiply it by 2. Okay, you have to multiply that one by 2. However, in number 4, they say, how many ways can the 6 Republicans and 6 Democrats be seated at a round table if they are to be seated alternately by party? Okay, so in my round table, when you do a circular permutation, this is a special situation. You don't put the 6 and 6 and 5 and 5 like we did in a linear permutation. Rather, you fix the first spot. Okay, so I'm going to put a little asterisk right here. That spot is fixed. Okay, and then let's say that's Republicans, and then next Democrats, and then Republicans and Democrats. So for the Democrats, there's 6 still available for the next spot. The Republicans, now there's only 5 available, and then Democrats 5. So that's, and then it keeps on going. So this ends up being 6 factorial times 5 factorial. And this one you do not double, because if you consider that first fixed spot to be a Democrat, well, that's just like taking your table and rotating it. That's not considered a different arrangement. But in a line, it definitely is a different arrangement, as you can see. If I tell you, hey, whoever's sitting in that or standing in that first spot, you get to be the president. Okay, so this is going to be my answer for number 4. And that ends up being, I'm doing the worksheet, not the quiz. But anyway, the quiz questions were very similar. So 86,400 for number 4. Okay, and then what was the third one? Number 15 on the worksheet. Okay, worksheet number 15. All right, this is back to the 2 dice. So it says a sum of 4 is rolled with a pair showing. Okay, so you can get a sum of 4 by going 1 and 3, 2 and 2, and then 3 and 1. There's 3 different ways that you could get a sum of 4, but they specifically said that there's a pair showing. So it's not this, it's not that, it's just this. Well, there's only one way to get a sum of 4 with a pair showing, and it's 2 and 2. So that's 1 out of 36. And that's your answer. Okay. All right. Let's move on. Kendall. Oh, yeah, I do have a probability review sheet. I am presuming that's you're in one of the classes where you haven't seen it yet. Perhaps that's going to be your homework tomorrow night. Okay, how do we know if it's combinations or permutations? Combinations, order doesn't matter. Permutations, order does matter. So keywords for combinations, oftentimes they'll say if you have a group of people, then the order doesn't matter. You just go, pick me, pick me. I shouldn't say pick. Choose me, choose me. You want to be in the group, right? But it doesn't matter if they chose you as the first person or the fifth person. If there's 5 people in the group, you got chosen. So that's great. Okay, but if I say I want to select a group where the first person is going to be the president, the second person is going to be the vice president of my club, and then the third person is going to be the secretary, the fourth person is going to be the treasurer, and the fifth person is going to be the communications or publicity person. Okay, well, then the order matters, because if you get selected first, you're the president. But if you get selected fifth, you're doing advertising or whatever. Okay, so then the order matters, and it has to be a permutation. Another key word for permutation is arrangement. Okay, if they say the letters are arranged or find the number of arrangements, that's a permutation. Writing words, and I'm putting them in quotes because if you take the letters out of the word sardine and you say, let's make 3-letter words, well, it might be SAR or SRD. They're not truly words, but it's just 3-letter groupings. And the order matters because SAR is a different word than RAS, right? So then the order matters. Okay, hope that helped, Andrew. Okay, Sophia, can I do T2 part C? All right, get to that page. T2 part C. Okay. So Andrew, listen to this. It says a group of 5 is selected at random. That means the order doesn't matter. What is the probability that it contains at least 2 boys? Okay, I was going to say we need more information than that. So let me go back to the very beginning. It says for problems T1 through T5, 8 first graders where you have, okay, so 8, I'm going to write kids, and it's 4 boys and 4 girls. So, hey, it's just like the red and blue marbles. It's just like the blue and green socks. It's just like the, what else did we have? 7 Republicans and 7 Democrats or whatever. They're telling us specifically how many boys, how many girls. Okay, and the order doesn't matter because it's just a group of kids. Okay, so if a group of 5 is selected at random, that's very important that you know that there are going to be 5 in our group. She asked for part C, at least 2 boys. All right, so I still contend if you don't write this beginning part, it makes it very tricky. When you do write this beginning part, it's like, oh, this is so easy. Okay, at least 2 boys means I might have 2 boys. Okay, but remember, our group of kids that we're selecting right now is 5. So if it's 2 boys, then it has to be and 3 girls. Okay, but that's at least 2 boys. It can be or 3 boys, and that would mean 2 girls. 3 boys, 2 girls for a total of 5. Or couldn't it be 4 boys? And then that would mean only 1 girl. And then I'm going to stop there. Even though we have a group of 5, I can't say or 5 boys because we know there are only 4 boys. Okay, so here we go. We're going to do all 3 of these and then we'll add them up. So out of the 4 boys, choose 2. And then means times. Out of the 4 girls, choose 3. Then for the second scenario, out of the 4 boys, choose 3. And then out of the 4 girls, choose 2. And then out of the 4 boys, choose 4. And out of the 4 girls, choose 1. Okay, let's see. This is 2C. They just gave me the final answer. I'm not going to take the time to figure out these numbers. Okay, you get some number, some number, some number. You add them all up. Okay, so add this plus this plus this. And then, of course, I need to divide by my sample space. Okay, so whatever number I get for that total, I'm going to divide by the sample space. And let me say that. Now I forget for sample space how many are boys and how many are girls. There's just 8 kids, and I'm choosing 5. Okay, that number, that over that ends up being approximately 92.85%. Let me do that all out, okay? So I'm not going to take the time to put those into my calculator. Okay, let's move on. Kendall, R, 4, D, and E. I think I've done that one. Let me look. Page 701. R4. You know what? I haven't done D and E. I have done E. That was the Amanda's. Let's look at D. How many different ways could the 7 letters be arranged in a circle? Okay, so we did R4, A, B, and C. And then D, a little bit weird putting it in a circle, but page 701, R4D. Okay, if I have 7 letters that I'm putting in a circle, I'm going to go 1, 2, 3, 4, 5, 6, 7. You fix the first spot, okay? That's what's different about a circular permutation versus writing your letters out in a row, in a line. Okay, after I fix that first position, now there are only 6 letters left. There's 7 altogether, but now there's 6, then 5, 4, 3, 2, and 1. So it's just 6 factorial. And so for R4D, your answer is 720. Okay, so that's just a special case of a circular permutation. You fix the first position, and then there's the remaining 6 letters to go around. Okay. Okay, so all right, so Kendall, I'm not sure. There seems to be some confusion about what worksheet I'm using. I can show it to you. It says Algebra 2 Trig, Chapter 12 Review, Probability, and the first 1 through 6 says there's 6 Democrats and 6 Republicans. Anyway, I'm guessing you're going to get this worksheet tomorrow if you haven't gotten it yet. Okay, so they've all been good problems, even though you don't know what the questions are. So that's unfortunate. Okay. Okay, I think I answered everybody's questions. I sure did. All right, perfect. It's 9 o'clock. Let's go home. We already are home. All right, I hope that was helpful for you guys. Practice. If you can kind of categorize the different types of problems, you know, you guys, we have 3 sections that we skipped from this chapter. The last 3 sections we don't do anymore. So you don't have that many different types of problems. You should be able to categorize them and be able to do well on the test on Friday. All right, have a great evening and good luck on your test and have a wonderful 9-day vacation the next week. All right, good night.